So far, we've learned how to compute the derivative of the sum and the difference of two functions, the product of two functions, and the quotient of two functions. And so that leaves us with the question of how do you compute the derivative of the composition of two functions? And so that rule is called the chain rule. And I'm not going to take the time here in these videos to explain to you why the chain rule is true. If you're interested in that sort of thing, I would encourage you to check out the book. There's good reasons you can show why it works, why it's true, but we won't cover it here. Our goal today in this video series is relatively modest. We just want to understand the formula and then learn how to use it in practice. So this is really just a computational skill that you're going to need. And so here we go. So chain rule says if you want to take the derivative of the composition of two functions, maybe to help us see this, we'll rewrite it like this. We're taking the derivative of f of g of x because that's what f compose g of x means. Chain rule says take the derivative of the outside function and plug into the derivative of the outside whatever you were plugging into the original function. So you're going to have f prime of g of x, and then you're going to multiply by the derivative of the inside, which is g prime of x. So that's the situation. I will take just a moment and to the side here point out something to you. When Leibniz was first trying to figure out the formula of f times g, not f compose g, he thought it should be f prime times g prime. And of course it wasn't. We learned that you have to use the product rule for that. But you can kind of see the formula that he thought should work for the product rule actually playing out in the chain rule. You sort of have this f prime times g prime. The only difference is you're looking at f prime of g of x, not f prime of x. But anyway, that's kind of interesting to notice that pattern. Okay, so before we work out some examples, I do want to point out to you another way of writing this. This is with the Leibniz notation. So if you have a function y equals f of, and then instead of x, we'll say f of u, and that's just a different variable. I can do that. But it turns out that u itself is a function of x, then ultimately y is a function of x. Do you see? When you plug u equals g of x into f, if u is g of x, these are the same. So you can replace u with g of x. And so really you've got an f of g of x sitting here. It's the same as this situation, right? Right here is the same as this, just a different notation. In this case, if you want to talk about the derivative of y with respect to x, you can do that because ultimately, even though y looks like a function of u is a function of x. And so y is ultimately a function of x, and dy dx is equal to dy du. Take the derivative of y with respect to u, and then multiply by d, that's a du dx. Okay? So that's the other version of the chain rule. We'll practice this. I'm going to rewrite that. This is a du dx. We'll practice both of these. We're primarily going to be thinking about this formula. So let's do an example together. So I want to compute the derivative of all of the following functions. And so the first one is sine of x squared. So I'm thinking about this and I'm looking for composition. And it's pretty easy to see. You can think of sine of x squared is the same thing as sine of x composed with x squared. Do you see it? When you plug x squared into sine of x, you get sine of x squared. And so now all of a sudden you've sort of got a clear sense of what your outside function is, what you're plugging into, and your inside function, what you're plugging in. Here's your f, here's your g in the formula. And so we just work it out. So I think of it more as the derivative of the outside, derivative of the inside, that kind of thing. So when I want to write down y prime, I want to take the derivative of the outside. In this case, the outside is sine, and so its derivative is cosine, plug in the inside x squared. Then I want to multiply by the derivative of the inside, which is just 2x. I'm not satisfied leaving this like this. I'm going to move this out to the front of cosine, and so my final answer is going to be y prime equals 2x times the cosine of x squared. And that is our first chain rule. Good job. Let's do another one. Let's look at a slightly different problem. Let's look at f of x equals sine squared of x. I'm actually going to work this one out two different ways. So we're going to work it one way using the chain rule, and then I'll work it out another way using the product rule. And so I want you to be able to work out, to think about the problem either way. It's really important. So we're going to think about it as a chain rule first. And so I need to think about composition. And I want you to realize that sine squared of x is the same thing as x squared composed sine of x. You're plugging sine into x squared. Do you see it? So here, we're going to take the derivative of the outside function, the derivative of x squared, and we're going to get that f prime of x, this f prime is the derivative of the whole thing. Don't let the fact that our formula, we wrote it in terms of f and g, throw you off. F in the formula is just the outside function, and g is the inside function, whereas here, I've named f the whole thing. We're going to have to be able to sort of be fluid and work with the situation. So f prime is the derivative of the outside. The derivative of x squared is 2x. Plug in the inside. So 2x plug in sine is 2 sine of x. Does that make sense? Then you want to multiply by the derivative of the inside. The derivative of sine is cosine of x. And so, of course, you can write f prime of x is 2 sine x cosine x. And now I do want to show you, looking back at the original problem, what you can think about this is taking the 2, pulling it down, left with the 1. So 2, and then 2 sine to the 1, and then multiplying by the derivative of whatever this inside thing is. That always works, it turns out. If you have a power, like a function to a power like this, you can basically use the generalized power rule, pulling the 2 down, subtract, make a 1, and then multiply by the derivative of the inside. That's exactly what the chain rule says to do, and we'll actually talk about that more in just a minute. But I also wanted to work out this problem as a product, and so I want you to realize that you can write sine squared of x is sine x times, not composed, I'll put a solid dot, not a circle, sine x times sine x. And so all of a sudden you see, oh look, I can do this as a product. So f prime of x is, the derivative of this one is cosine x times sine x plus sine x times cosine x. And so this is exactly, when you get them both the same order, 2 sine x cosine x. So this is f prime of x. So either way, right, the answer is 2 sine cosine. And of course, if you really want to use a trig formula to write this as sine of 2x, you can, although I don't really see any real reason to. So let's end the video here, and then we'll go on and do some more examples in the next video.